Okay, so we are getting there. But first, here's a little plan for today. As always, day 17 already. Um, not a lot of days left. So we are going to quickly talk about how your final grade will be determined. And we may have a Q&A session about this. Um, we will say goodbye to rational functions with an interesting question. Um, we will begin our trig explorations with a GeoGebra video, a little investigation, and a little quiz. Then there's a Desmos assignment for practice, but that will be at your own pace. So let me go first. Well, let me go to the very first one. Okay, so we're going to keep meeting like we are and recording like we are. And you will have different tasks, different assignments that sometimes we'll do in class for the people who are with us, and sometimes people can do afterwards after they watch the video. So because of the time being very tight, there is really no time to have quizzes or big tests or stuff like that. So final grade, how is it going to be determined? I'm going to keep updating your evidence records. We will continue. We will continue. I laugh because you can't hear it, but I'm hearing these little dings every time people come in. And basically, if you are more or less doing your best in the assignments that we are assigning, you will be okay. I'm giving you feedback. I've always said I'm more interested in what you can learn. So hopefully you'll be able to keep demonstrating what you are learning and not worry so much about a final exam or a massive final summative or stuff like that, because there won't be anything like that. So we will basically continue work on the way we've been working, and you will have updates on your evidence records. And the last bit of news is that, and you'll be happy to hear this, your mark will hopefully go up. I don't think anybody will go down. So your mark hopefully can only go up. All right, and there is our John. Okay, so I just wanted to clarify that for everybody, so you hopefully don't worry too much. I don't want you to worry about your grade. We have spoken with universities. I said this to you before, and universities know the circumstances, and they're making plans to support students that will be coming in, universities and colleges. So, okay, enough of that. And if you have questions, please put them on the chat. Magically, I'm able to see the chat now, so I'm very excited about that. And I'll be able to answer the questions as we go along. So good. Okay, so here we go. We're going to start. Oh, I just lost the chat. What a dork. Scusi. How did I do that? Let's see here. I have it again. Okay, good. This is John. I know, John. It's good to see you, man. Okay, so here we go. No, that's not benign. We are going to go and we are going to do our classic random groups. So for those of you who may not know where it is, let me show you, because I don't want to miss that part. If you go to our homepage, you will see here, you scroll down. Well, you can do it in content here, either here under content or here on their, it's the same thing, content browser, recorded classes. So if you go here, you can scroll day 10, 11, 13, 14, 15, 16, right? So they are all there, or you can come here. And it's not a bad strategy. If you have questions, go give it a look. This already, like I said before, these videos are already summarized. So they're here, okay? For whatever the days, there's no video for day 12, but all the other ones are here. And I usually put a little topic for you to have an idea what we discussed that day. Good. Okay. Good. So here's okay. So before you, well, there's the open middle Jamboard. Okay. So you're going to click here and you're going to go to the Jamboard. If you haven't been here with Jamboards, I think all of you have actually, but just as a quick reference, here's the Jamboard. It has a very interesting question. It's here. Okay. So stay with me for a moment. And then you can go on your respective team, right? Group 1 here, group 2, group 3, blah, blah, blah. Okay. So we're saying goodbye to rational functions because we kind of have to. And here's the question. I'm going to try to clarify something for you because some of you may need clarification. Okay. So here's a function. F of x is a linear divided by a linear. Something x plus something divided by something x minus something. Okay. And this is your task. You're going to use the digits 1 through 9 to fill the boxes. You may not repeat a digit. Okay. So in your group, you may put here whatever number you want. Let's say 1, 2, 3, 4, 5, 6. And of course, this has to work. In other words, the vertical asymptote has to match, the horizontal asymptote has to match the function that you put here. Okay. And you cannot repeat digits. Be aware of that because hopefully you'll discover a few interesting things. These are the teams that I have found got it right. Please, if your team got it right and I don't mention your team, do correct me, okay? Team 1 had it right. Actually, team 1, I think might have been the very first one to find it. So team 1, I need to see, Amber and Malcolm. Tell us a little bit about the process and then how you were able to find the first one. And then did you find more than you kept finding stuff? Okay, so we'll listen to you.
So basically, we just started with the asymptotes first. Once we set a number that we were trying to divide into, then it became easier to fill in the rest of the blanks. We just kept playing around with numbers until we found things that kind of worked and satisfied one another.
Amber, anything to add?
Yeah, so like originally Malcolm pretty much did most of the work because I didn't really like understand like how to do it, but then I realized if I put some of the numbers into Desmos, then I could like look at the Desmos graph and see like the vertical asymptotes and the horizontal to make sure that it satisfied like what it was asking for. And that's pretty much just what I did to like help find the rest.
Awesome. Very cool. Very cool. And I can see here the answer that you guys had. That was kind of one of the last ones. I did something a bit evilish with this team because I believe they were the very first one to come up with a solution and everybody was still working. So I went to them and I asked them to see if they could find more than one solution. And they didn't, at least as far as I could hear, they didn't think very bad things about me and they just went at it, which was pretty amazing. So there's all these, I believe, work. Now, there's something that we want to comment about. So this is the first group. I believe group 3 also did this. And I don't know if there's something here that is similar. Actually, no, I think it's a different equation. So group 3, which is Jonathan and McKenna, can you walk us a little bit through these, please, or your process?
Yeah, so first we used 6 and 2 for the first two numbers with the x, and it worked out for y equals 3, the horizontal asymptote. And then for the 7 and 8, we just it was just like trial and error, and we used Desmos also, and it worked for that one, for the vertical asymptote. It equals 4, x equals 4.
All right, awesome. The next, thank you, Jonathan. McKenna, anything to add?
I think her mic's not working.
Oh, right. It's true. Okay. So then if you want to add something on the chat, feel free. The next group that I believe got it right was, I mean, a lot of you were so close. I mean, these team work hard. They try things. A lot of there were a few of these teams, for example, here. Sadly, this is duplicated, right? Because we have the 5 and the 3. And this was something I kind of, when I did this question myself, realized that there's some numbers that just I can't put because they're going to be repeating. But same thing here. Team 7, and Team 7 is Kate and Andrew. So I don't know if we've seen something similar. Maybe we did. But can you walk us a little bit through your process and look at them? They're celebrating. I like that a lot. That's so cool. All right, so we're listening to you, Kate and Andrew.
Okay, so basically we just kind of did trial and error, but we used the bigger numbers on the top so that we could divide the numerator into the denominator easier. And then we just used numbers that went into each other on the denominator. So when we were solving for x and set the equation to 0, it would be easier to get a whole number, I guess.
Nice, nice. See, as you play with the numbers, you begin to see some kind of patterns, right? So well done. We've seen these several times, the 6 and the 9. And then, of course, we want to put something here that allows us to find the other asymptote without duplicating anything. So well done. The next team that I think got it right, this is another one that is close, but there's duplication here. Team 10. And Team 10, I think, went to town because they found one solution here. I let them talk. Team 10 is Inalua and Steven. So we're listening to you, friends.
Okay, so at first we kind of started backwards. We decided to pick our favorite numbers and we'll like solve for that. Didn't really work out because of duplication, so we just kind of started playing around with it more of. I know that Stephanie went on Desmos, and I just kind of continued on with trial and error. Then we kind of came to the same conclusion. And as we were going through, like most people, I noticed the pattern that you kind of needed to have bigger numbers in the numerator, and at least so like everything divides evenly. And then I also realized that everything should have a common factor, like at least in all of them, there should be at least one number that they all divide into, which makes it easier. So you can have like a 5 and 7, because that would be really hard for anything to get divided into. So like, yeah.
Cool. Steven, anything to add?
Yeah, one thing I think we discovered towards the end of the assignment is if the numerator, to solve for the the horizontal asymptotes, is your numerator has to be bigger than your denominator. But I've noticed is if your numerator and denominator are always even numbers, they will never repeat themselves. Like 8 divided by 2, 8 divided by 4, right? Like it's even numbers don't seem to repeat themselves. So that's what I started with on our third example, was just eliminating even numbers to solve for the y asymptote, then just kind of plug in the rest.
That is brilliant. That is brilliant. I did see that pattern too when I play with it. The even numbers, brilliant. Thanks a lot, Stephen. And last but not least, Team 11. Very minimalistic, very effective. So Team 11, Malvi and Sarah, we're listening to you.
I don't know if Sarah wants to talk, but I'll just say, so what we did basically the same as kind of what everyone else did. We started with trying to find a horizontal asymptote. So I did 6 on top and then 2, because then just like what Steven said about the even numbers, I kind of noticed that too. So I used those even numbers and then got the horizontal asymptote, and then I dealt with the vertical asymptote at the bottom. So I just tried to find numbers that wouldn't repeat itself, and I got the 4 for x. And then for 7, for that value, I kind of realized you can just put any number that hasn't been used, because it doesn't really make a difference. And, yeah.
That is a very good point. There's these number, it's almost irrelevant, right? We could almost actually, I think we could change this number for anything. And so that's a very good observations and discoveries that you have made as you went along, right? These 7, we could almost put anything. These, look at the even. numbers pretty good. Pretty good. This was fun. Sarah, I don't know if you want to.
Her mic doesn't work.
I know, but she can add something in the chat if she wants to. Oh, sorry. I thought I sent it to Sarah, and I sent it accidentally to Malcolm. I need to send it to everybody. So anyway. Yeah, okay. So no, not successful. All right. Thank you. I hope you like it though. I love this question, and it's a good way for us to kind of say goodbye to our rational functions for this time. Again, I wish there was so much more stuff about rational functions, but our time together is shorter. So I need to kind of pick on some key ideas from the course that I think you will benefit. But I think these notion of the asymptotes and the relationship that we've been exploring will be beneficial to you later. As always, the Jamboard stays up for you to go and check. And of course, please, well, anybody can see the video if you want to, because some of the ideas that you shared today have been really spectacular. Good. Thanks a lot, Sarah. Everybody can see your comment. Yeah, well done. Thank you very much. Okay, so this was fun, but it took a bit of time. So I'm going to take you to kind of what is the next plan, and I want to ask you something. So what we have next here is the following. Stay with me for a moment. Don't go anywhere. Let's do this because again, I'm very mindful of how much time you can be working on stuff. There's a quiz, okay? Don't do the quiz yet because I'm not sure you will be able to. I just want to show you that it's in quiz. And when you act here, and it has a couple of directions. So there's a link to a video, okay, that I want you to watch. The video is about 12 minutes long. And there's a construction that you're going to do in GeoGebra, okay? And then you can do the quiz. So I'm just going to do the following. I'm going to walk you a little bit through the GeoGebra construction. I don't want to give it away. And sometimes it's tricky to try to do it all at once. That's why I made the little videos, like the machine that we build, the constant difference machine. So this is what you're going to do. GeoGebra, we play with it a bit. We're going to play with a different part of GeoGebra, okay? So if you can stay with me for the next 3 or 4 minutes, then when you watch the video and you do the quiz, you will breeze through it, okay? So you're going to go to GeoGebra, and all of you have, I believe, accounts. Okay, you created accounts before. I know for a fact because we have a group. I'm going to show you the group. Of course, this was a while ago. We did this for the, here it is, for the odd and even functions investigation. You're going to go to GeoGebra, to this page. You will see here, it will have your name. And we're going to use a tool that is very nice. It's called a calculator that is a geometry calculator. So you can find the geometry calculator here, actually. Geometry. You can find it here, or you can find it here. And this is what it looks like. Doesn't look like much. It's a blank piece, but it's amazing. So what we're going to be doing is we're going to be playing with some circles and angles and stuff like that. So you're going to begin by building a circle. So this is how this works. Let me just make sure that I think somebody just came in. No. Okay. So 2 key ideas in GeoGebra that will save you a lot of grief. And if you remember these, you'll be dancing in the streets. When I click on one of these tools, look at the bottom. You see what happened at the bottom? It tells me what I need to do. I'm going to do it again. And it says circle with center through point. select center point, then point on the circle. So I'm going to activate this tool. I come to my workspace, I click on my mouse, create point A, and as I move my mouse away, whoa, I'm making a circle. And then I click again, and now I have a circle. This is the second important idea. This will save you a lot of grief. Right now, the tool that I'm using is the circle. If I want to do something else, I need to come here. In other words, until I tell GeoGebra that I'm not doing circles, I'll be doing circles. And the way I tell GeoGebra is here. If you forget that, this is what may happen. You do the circle first, and you're still in the circles, and then we want to do something else, and you do this, oh, and you keep building circles. And you go, holy smokes, what's going on, right? And that's not what you want to do. So, of course, you can always undo here or redo, but then remember to come here, okay? And then it tells you, the tools are very beautiful. When you open them, they tell you what they are. I just wanted to mention these to you because I mentioned it in the video, but it's an easy mistake to make, those two. If you're not sure how to activate something, look at the description. And I would suggest almost every time you do something, come back to the arrow. So then you reset kind of thing, and then you can go back to the next tool. You're going to make a construction, and after you make your construction, you are going to save it. You're going to go here, save, and you're going to save it to your account. You can give it a title, whatever you want. This instruction is at the end of the video. I made the video, and then I forgot to put these, and then I added at the end. It's there, but it looks like the video is ended, but it hasn't. And then you're going to add it here, give it a tile, and then later when you come here, actually when you go back to your page, yeah, it tells me you're not going to, yeah, it's okay. You are going to come to your profile, and you can go to groups better. Groups, and when we go to our home page, the GeoGebra code is here for the group. So you're going to do your construction, you're going to save it, and then you're going to go to groups, yeah, PBQEY, and what you would do would put the code here, PBQEY, and then go to my join. You're already in the group, so you can just, actually you're already in the group. You don't have to enter the code, you just go to my groups, and you will see the group here. You don't actually need the code. You go here, and the group will open. And what I want you to do is go to resources, and then add a resource here. I think you can add it here. But if you have trouble doing this, don't sweat it. So long as you make your construction and you save it, then we'll find it, okay? I think you can add it here, or add a post with the construction that you made with your name, okay? You can do that. There's one more thing that I want to highlight because of time. We have a Desmos rational function exploration number 3. I need you to look at this because I don't want you to be angry with me after. I made this assignment optional, okay? If you want to do it, lovely, fantastic. If you don't have time to do it, it's okay, all right? So you can do it or you don't. Don't feel bad if you can't, okay? There's another Desmos that is due later. I don't expect you to go into these Desmos either. So basically what I'm asking you to do between now and Monday is go and work on this quiz. See the video, work on the quiz, send me any questions you have either on Remind or here, and then that's it. The next Desmos is optional. If you have Desmos that you haven't finished, do finish them. Don't sweat the deadlines. I mentioned that last time. And that's it. So I'm going to tell you that you friends can leave whenever you want, and that I'm going to hang around here till, as usual, about 8:40 or so for anybody that has any questions. Now, before we say goodbye to some of you, I'm going to go to the chat. Please, if you have any questions about your grade or something like that, either ask them now or put them on the chat, because some of you may have the same question. And I know sometimes some of you are very humble, you're very shy, but you do have questions. So please, if there's anything that you need answers to, please put them now. And if you don't have questions and you're cool and you need to go, do so. If you want to stay and work on the quiz and the GeoGebra, that is chill too. And you can submit that quiz when you finished. Andrew is asking, is it true our marks cannot drop from your midterms? That is true, Andrew. Madiha is asking, can we fix our previous assignments? And the answer to that is definitely yes. The only favor I do have is that you please let me know if it's assignments that are a bit oldish. If you let me know that, send me a quick note on Remind or an email, say, Mr. Garcia, this thing I went and reviewed, and then I will look at it. Otherwise, I don't know. Right now, I'm looking at two assignments. One is the two Desmos rational functions, right? The Desmos linear, reciprocal of linear and reciprocal of quadratics, which we've been working on for a while. We have a lot of evidence of work that many of you have done on the Jamboards. I'm looking at the exit ticket that we did for the snow shoveling that many of you have submitted. And if you're not sure where that is, it's under assignments. You're seeing my screen. You can find it. Oh, but I need to show you like a student, don't I? Okay, under assignments, you should see it. Shoveling the driveway exit ticket. Yeah, a lot of you have done it. So I will try that. And Sabahat is asking, how do we go to previous Desmos to see our answers? You just go. You have access to all the Desmos, Sabahat, under assignments, right? So if you're looking at my screen, for example, if I'm a student, I can see the Desmos that are here, and then every one of these has the links. You can also go to your evidence record and see where you are on your assignments, right?